Now the calculator is going to calculate the expected values for you, and it's going to place them into matrix B. So remember, each one of those expected counts, the calculator took the row total times the column total for that cell, and in this case it divided that by little n. Our sample size here was 934. So the calculator made those 8 separate computations for you and wrote each of those results into the corresponding cell into matrix B. So to see the expected values, you're going to go into matrix and choose 2 for matrix B and press enter next to that. Okay, so now we've got some long decimal places in here, so that we can press the right arrow to see the entire matrix. So in here we've got a lot of decimal values here, so again, if we just right arrow over to keep scrolling, we can see all those other values. So if we do that, if we round those values to 2 decimal places, we get the following matrix of expected values. Okay, so there are 8 of them. This is also 2 by 4, just like our matrix A. And now remember, at the very beginning of the test, we had an assumption that all of these expected values needed to be at least 5. So we should notice that all expected values are greater than or equal to 5. Okay, so 228.58 is definitely greater than or equal to 5. 195.3 is definitely greater than or equal to 5, and so on. Our smallest cell in here is 23.72, and it is also greater than or equal to 5. So again, that was the assumption that needed to be met for the test from the very beginning. Our matrix of observed values, so if we go back to the 2 by 4 in the contingency table of observed frequencies, we have this. Okay, so each of these, so here we have 8 values of the observed counts, and here we have 8 values of the expected counts. And we're going to use those values here in just a second when we set up this formula. But in StatCrunch, again, we would enter the contingency table like we talked about at the very beginning here. We would hit Stat Tables Contingency with Summary. Under Select Columns, we would choose the columns None, Less than 2, 2 to 6, and More than 6. And then under the row labels, we would choose Autism. And then under Display, we would ask it to show us these expected counts so that we can check that they're all at least 5. Okay, so on the calculator, or in StatCrunch, that would look like this. So under Select Columns, okay, we selected None, Less than 2, 2 to 6, More than 6. Under Row Labels, we would pick Autism. And then next to Display, we would highlight Expected Count. And then we'd click Compute to see the output. Okay. All right, so here in the cell format, it tells us that, it says count, where really that is, it doesn't have the word there, but that's really the observed count. And then in parentheses underneath of it is the expected count. So in this first cell, we've got 241 and 228.58. Okay, so if we go back up on the calculator, that is the 241 that was observed and the 228.58 that we expected in that corresponding cell. Okay, and so each of the 8 cells in our contingency table that we had, each of those has an observed count along with our expected frequency for that same cell. So again, no matter what technology we use, we're going to get the same value of chi-square here in the end. And we are going to set just one of these up so that we kind of understand what this is actually measuring. So this chi-square value, to try to measure the gaps, it's going to take each cell and it's going to take its observed value, so like 241, minus what we expected in that cell. And then some of those differences are going to be positive and some negative, so we're going to square each of them. And some cells we expect more things than others, so again, we're going to scale each of these accordingly by dividing by what we expected in that cell. And then this big summation we're going to add, and we need to do this to all cells. So we're going to have 8 of these terms in here when we're done, although we're not going to actually write all those out here. So we're going to take 198 minus what we expected in that cell, and we're going to square that, and then we're going to divide by what we expected in that cell. Okay, and we would keep doing that for each of the 8 cells until this last cell here where we would get 44 is what we observed. The expected frequency was 32.17 squared. And then again dividing by what we expected in that cell. Now, if we actually went through and computed all of this, again, that chi-square value on the output screen here, we see it's roughly about 11.22. And if we scroll back to where we saw this on the calculator, we also saw a value of about 11.22. So again, it doesn't matter which technology you use, it's all running the same computations in the background to compute those values. So chi-square here, if we round off to 2 decimal places, is about 11.22. Now, this chi-square test statistic does not measure standard deviations away from a claim. So when we T statistics and Z statistics, we would talk about how many standard deviations above or below the claim we were. Chi-square test statistic does not measure that. So we're going to have to really rely on the p-value here to tell us about how unusual or not so unusual our result is. So again, obtaining that p-value and then making a picture to show what all these numbers mean. So again, if the observed and expected frequencies matched exactly, then O minus E would be 0. Squared would be 0, divided by E would be 0, and then we'd add up a bunch of zeros, which would give us 0. So if they matched exactly, the chi-square value would come out 0. Okay, so in this case, this is our claim, is that under the claim of independence, we would expect a chi-square value really close to 0. Now, any differences will keep making the value of chi-square bigger, so the chi-square tests are always right-tailed tests. And so in this case, the p-value, and again, doesn't matter if we look at StatCrunch or if we go back up and we look at it from the calculator, it is about 0.0106. So that p-value is going to be the area in that right tail. Okay. And that 11.22, we write on here right at the cut score, okay, between the unshaded region and the shaded region. So that shaded region starts at a chi-square value of 11.22. All right, so that p-value, just as before, it's either going to be less than or equal to alpha or greater than alpha. In this case, our alpha value was 0.01. So in this case, it's enough bigger. Okay, so that's why p-values we usually carry out to 3 or 4 decimal places. Okay, we wouldn't want to round this to 0.01 because then we would think it was equal to 0.01 and we would end up rejecting, where instead we should fail to because it is slightly bigger than 0.01. So in this case, since the p-value is greater than 0.01, we will fail to reject HO. All right, so just as in the last sections, if we fail to reject, that means this is going to start out there is not significant evidence to conclude. And if we go back and just look at what we wrote for HA, we are going to say to conclude that breastfeeding timeline and autism are dependent. So this means that we can't say that whether a child is breastfed or not will influence the chance that the child will be diagnosed with autism. Now here the p-value, or I'm sorry, the level of significance alpha was set pretty small at 0.01. Had it been set at something like even 0.02 or 0.05, we would have ended up rejecting HO and saying there was a significant evidence. Now in doing that, we just increased the chance that we made a type 1 error. Okay, but in this case, with that being set at, with alpha at 0.01, we do not have enough evidence for that level of significance.